So again, you may notice on this first one that I specified how many rectangles you need to have, and that's 5. But I've only gone from 0 to 2. So is each one going to be 1 wide? No. Each one's going to be considerably different. And basically, if you know you're going only from 0 to 2, and I'm asking you to put 5 rectangles in there, how can you figure out how wide each rectangle is going to be, Darren? Yeah, basically what you do is you take this farther number and you subtract this number. So you basically take 2 minus 0, which is pretty simple on this one. And then you divide by how many rectangles you need, which is 5. So each one is going to be 2/5 wide. Well, that's, not the best number in the world. All right. So basically it gets a little harder to figure out where those would divide up. But what I've done, and now this is LRAM. So LRAM means that the rectangle should hit on the left. And so it should look, come on, there it is, something along those lines. And it's probably going to help you to be able to draw those in. Eventually you will know how to do them without having to draw the rectangles in. But some of the stuff we're going to do this year, it's very helpful to kind of know the rectangle theory because it really doesn't go away. And maybe we'll kind of, you can number them if you want, say rectangle 1, 2, 3, 4, 5 if you want. You don't have to do that, but I'll refer to them that way. So rectangle 1 we know is 2/5 times something. How do you find out basically how tall is that first rectangle? Well, if you put 0 in for an x value, that'll tell you how tall that first one is, right? So how tall is that one? That one's 5. Well, that one, not bad, right? That one we can do. But rectangle 2 is, again, going to be 2/5 times, well, that number, probably not as nice. Okay, you can figure that out on your own if you want. That's up to you. You would put 2/5 right in there, make it square it, make it negative, and add 5. This is where I'm going to suggest you might want to use the calculator to give you a little assistance. Now, how can the calculator be helpful here? Yeah, the table setting. It's going to be very helpful. So what we're looking at here is negative x squared plus 5. And so let's go ahead and do that. So you go to y equals, and I don't want any of those. So we'll get rid of those. And so it was negative x squared, and there it is, plus 5. Now you could go and graph it, but what I would do is just use the table, because that's what's most helpful on this particular one anyways. So you go to table set, which is second, and window. What do you think? With the graph we're looking at starting at -2, is that where we want to start? Yeah, why don't we start where we want, which is most helpful to us would be 0. Now what do you think? If we're going up by 2/5, you could type in 2 divided by 5 if you want, or 2 divided by 5. I think we should be able to figure out that decimal is 0.4, because 2/5 is 4/10, right? 0.4. And now how do you get the table to actually come up again? Yeah, you hit table. So second and graph. And so there is actually our y values. Well, here's the first y value. We knew that one, right? And so then our next y value is going to be 4.84, and 4.36, 3.56, 2.44, and the last one there. Now we got to figure out which one of those we need. So now you still have the calculator in front of you, and so you can kind of keep that. But let's try something quick here. So at point 4, which is this one, right? That'll tell me how tall which rectangle is. 1, 2, 3. That tells me how tall 2 is, right? And how tall is 2? Well, it's 4.84. So basically, here's where I would number them. Here's rectangle 1. Here's rectangle 2, right? Just so you can keep track of it. So here's 2/5. This is going to be rectangle 3. So which y value am I going to use over there of the ones we've got? 4.36, exactly, because here is 0.8, and that's going to tell me how tall that is. So 4.36, so plus. Why is it 2/5 every time? Because that's what? That's how. Okay, interval is a good word. I wasn't anticipating that one, but very good word. But basically, that's how wide each one is, right? This right here is 2/5, 2/5, 2/5. And then times, well, 3.56 would be that next one, because that's right here. And now the last one, a lot of people are going to say the last one is 1 unit tall. But my last rectangle is not 1 unit tall. It's actually 2.44 tall. So this is rectangle 4. So 2/5 times, what is it, 2.44. So how come I don't use 1 on this particular setup? Yeah, it's left, not right. If it was 1, it'd be hitting right there. Okay. So once again, this approximation is going to be a little bit big, right? And I know it seems like a pain right now, but in the end, once this limit process helps us out, this is going to go real quick. So you have to be patient with me. But I want you to know where it's coming from. Now, here's another way I look at it. Now, yesterday, when I gave you, or actually 2 days ago, when I made them all 1 wide, none of you even wrote that down, did you? Basically, what you did is you factored that 1 out front and said, forget about it. Am I multiplying every single one of these by 2/5? So could I have made this a little quicker for myself? Yeah. You could have done it like this. All right, 2/5. And then just done 5 plus 4.84 plus 4.36 plus 3.56 plus 2.44. The reason I caution showing you that right away is how many people you think then you put plus 1 and keep going. A lot of people go too far. But if you have 5 rectangles, 5 heights, right? That'll tell you when to go. Either way is going to get you to the answer. So go ahead and do that math right now. And let's compare what we're getting here. Or we could always type it in if we have to. Oops. I think this is going to work. Let's find out. 8.08. And this answer is going to be a little bit big to what the actual answer is because of these areas right there. It's not too bad, though. What I would like you to do right now, and obviously you still have this on your calculator, so you don't need to see that up here anymore. I want you to go ahead and try doing this one. But you have a lot of the math on there already. If you look up here, you almost have everything you need, except one of those numbers you're going to take away, and you're going to add another number somewhere else. Because this is a right-handed, which means your rectangles that because they're hitting the right side. So in those parentheses up top, which number is going to go away? 5. Which number is going to take its place? 1. And pretty much you probably should put 1 at the end because that's really where it happens, but that depends on how you are perceiving that. Because do I actually have it hit it at all right there anymore? And no, I don't. And now I do actually have it hitting here at 1. All the other values are going to be the same. You got to realize there's a 2/5 out front, so be careful. But now you can write it a little quicker. Put the 2/5 out front, write all the other numbers, and replace 5 with 1, and you should be able to get it. First answer is just 808. Units squared, if you want to look at it that way. And for the right-handed, this is going to be a little bit short because we are missing those. And so what did we come up with for that particular number? 6.48. There you go. Any questions? Now you notice how close those actually got, and again, maybe mentally picture what if I would have said 100 rectangles and how accurate that would be. Or say, take the limit and get as many rectangles in there as you can and let the calculus do it for us, which we will eventually do. But you got to prove that you can do this for me first. Next one. Now it says use 4 rectangles to calculate the right and left approximations. We're going from 0 to 2. It is x squared minus 4. That's why it's down so much. And so notice that I've given you the right-hand one first, though. So get a picture in there. There it is. How come my picture seems to be missing something? I thought it says 4 rectangles. Why do I only have 3? Yeah, because this last one here, really, you could say it's that much, but it's only times, well, 0. So there's no rectangle there. Okay. Now, how did we figure out how wide each one was again on the first problem? How did we do it? Basically, yeah, you take the furthest minus this one. Is it always going to be 0, though? No, I could change that up on you. But yeah, you basically take 2 minus 0, divide by how many rectangles you want, which is 4. So each one is 1/2. Okay. So now here's where you're going to want to use that table method, but don't use 2/5 as how you want your table to go up unless you want to do it by hand. And so 1/2 is something you can leave out front. All right, and go ahead and find out how tall. Again, you can number them if you want. That's up to you. And then go ahead and try the left-handed as well. Let's see if I can find that one in here. Okay. Because and this is why I did one that's upside down, to kind of show you how it could change things. So go ahead, take some time and do that, and we'll see how you do. All right, let's see how you did. Once again, it's important to realize that 1/2 is basically kind of now that width that you can put out front, and then we're just going to add up the heights. For this one here, you look in my table here, am I going to use the -4? Is that one that happens for this particular rectangle? Well, no, that would be if it hit on the left side. So the first one is actually at the 1/2, and so now does it seem strange that there's negatives? No. This is something we're going to have to talk about a lot soon, is that, yeah, these are negative numbers, and so we have to realize that, sometimes calculus can only do so much. Sometimes you have to be logical about things. And so this next one is, what, -3? And then the next one's -1.75, and the last one is 0. Now, you say, do you have to write the 0? No. But what some people do is they always write everything because then they can come back and say, okay, 1, 2, 3, 4. I got them all. Instead of wondering, wait, how come I only have 3 numbers? There's supposed to be 4 rectangles. Did I mess up? You know, some people just write it in there anyways. And so you go ahead and you do that math, and really you get a negative answer. Is that acceptable to have a negative answer when the question specifically asks about area? Is negative area okay? Not if it specifically asks about area. So what you need to do is simply change it to a positive. Yeah, make it an absolute value. That is a legal move, and we're going to have to talk about that when we get to what calculus does. So you change your answer to positive, and what did you get? 4.25 units squared. Now, when we use calculus and use that limit process, it basically does this math for us, so your answer when you do calculus is going to come out negative. And it's your job to realize, wait a minute, that was below the x-axis, and that's why it's negative. Okay? So basically, you're going to do the same thing for the one that's over here. We'll get this out of the way. With one small difference, yeah, you still got the 1/2. Now, of these numbers down here, which one basically is going to go away? Okay, 0 is going to go away. And then what do you replace it with? Yeah, a 4 out front. And notice that I did them in a different order. Well, it'd be -4 technically, right? Yeah, you know, -3.75, -3, -1.75. And this answer is 6.25, I've been told. Units squared. These are both very good approximations. Any questions? I'll have to get that for you. It'll take me just a second.
Yesterday you said it would work.
Okay, the question was taking the range, and what do you mean by that?
By adding those two together by going to
Oh, the average. Because taking the average doesn't work because it is a curve, and this doesn't necessarily get canceled out by that. That's when average would work. If those two were exactly the same, it would work out that the average would work. But they don't necessarily work that way. But do you notice that even though it was under the x-axis, we still took our rectangles to the x-axis? It didn't change anything.